Thank you for coming for an unusual talk in terms of subject and also in terms of position of our speaker. It's my great honor to introduce you Professor Gao. He's one of the deans at Fudan University in Shanghai. And I think there is nothing more beautiful to imagine the difference between Martigny and Shanghai. Right? So we're discussing just a few minutes earlier, and they are having quite a lot of works with the hospitals in Shanghai. There are 19 hospitals in Shanghai they are collaborating with. And I think the city is like 24 million people.
Yeah, it's a bit large.
So here we talk about machine learning using wireless communication. But what I wanted to mention about him, you all have his bio, is he's one of the rare examples of really multidisciplinary researchers. I've been observing his career for several years. We're a colleague in London, and he's one of those people who will go and search for expertise elsewhere to build things that nobody else can build. And so he's been working on hardware, communication, signal processing, machine learning, and you name it. And I'm looking forward to his talk about parallel split learning for wireless network and his Professor Gao.
Okay, thank you, Andrea. Good morning, everyone. I'm really glad to get the invitation and come to see Andrea in his center. As Andrea mentioned earlier, that we used to be colleagues in London, Queen Mary University of London. But more accurately, Andrea is my mentor and helped me to growing to becoming professor. And that's the story behind. And I spent around 20 years in the UK, studying and working at Queen Mary University of London. Back to Shanghai around 2022 to mainly for family reasons, but I surprised to see what's happening there, because it's also for me is a new journey for me to work in Shanghai. So today I'm sharing some studies I have been working in the past 2 to 3 years by using the learning tools and to addressing problems in wireless communications, especially from the network level. As Andrea mentioned earlier as well, I'm more building the systematic research. So normally grab a problem and gradually building a system around the problem. So this is more my first step to understand whether I can building some scientific research or more oriented to publications. So this is one of my first students at Fudan University, Zheng Lin, the first author of this paper, who came to me, and the time when I came back to Fudan, and we discussed the idea, and then we rolling out a paper about this. So I will expand the idea, but surprisingly, this paper I just come out in 2014, early this year, and then got 49 Google Scholar citations. We are really surprised with this, but I still don't know why is this, but I hopefully through sharing what I can explain the work and to understand a little bit more for the interesting parts. So I will briefly introduce from 3 parts, from the background, and then the efficient parallel split learning, the EPSL, but surprisingly close to EPFL. And then I'll pointing out a little bit future directions. So as I think the story even much beyond this is that this year Apple released this Apple 16. If you're looking at that, computing power is around 23 flops, and is already becoming a power devices. So the wireless network is already pushing the computing ability to the edge, to the device level. And for that level, most application intuitively is for apps and for applications. But for my work, we're looking for the application level down to the transmission and the computing together. So in the current development of the 6G, currently we are using 5G. We're developing 6G. I was at the ITU to attending the related meeting on this. Is that the 6G is developing into more on the AI-driven approach. So on the edge, as well, close to the base station, we can see around on top of the building. And then from base station goes to the cloud or data center. But for communication network, before the cloud, there is also the communication core network. So currently there are trends, they are moving these two core network and data center into one type of unit. So the 6G normally at ITU is the IMT 2030 and developing a lot. And there are different countries, different regions. In Europe, we have the Hexa 6G projects, and in China as well, they're developing. And one of the leading company in telecom currently is the Huawei and Ericsson and a few others. And then they work out the ITU standard. They are pushing now into hexagon shape, but it is 6K domains. One of those is the AI, integrated AI and communications together. And there are standards, and you can check the ITU standards. They are already putting in some of those, and Huawei also publishing some of their ideas how to build such a scenario. And they're deploying the distributed AI at the network edge. And as I just briefly touched the Apple iPhone 16, that one is that they also released the Apple Intelligence. So the model is that they're doing this some local training at the or local inference at the Apple device, iPhone, and then some at the Apple's local cloud, and then some goes into the big model goes to the OpenAI, the more AIGC stuff. So for the network is also happening in a similar way, and we're looking at using the AI technique, distributed AI techniques to solve the latency and the bandwidth, and then the privacy and a little bit related to security issues, so that we can supporting more sustainable development of the network more across globally. So for this AI distribution stuff is not a new concept, especially for different applications and for wireless networks. Also, a lot of people we intuitively think we can use the federated learning, and that's the model already being distributed around the wireless network in China Mobile, probably in Vodafone as well. Those companies are already starting to train the model in the way as separated through the device, and then sending the trained parameters, and then goes to the edge cloud, and then do the complete set of training through the federated learning models. But as we've seen that in the past 2 to 3 years, the OpenAI and the AIGC, the ASI is all coming out. So the generative AI models get larger and larger, from closed world to open world, and all the way to now a lot of newer models to come out. So once the model come out, we require more generic requirement of the AI applications. It will leading to the device have very limited power, although the computing power is growing for the device, is still very limited for large language models. So therefore, the federated learning schemes is becoming more and more impossible to apply for such a network applications. And therefore, in early days, around 3 years ago, the split learning starting coming out. We're not separating the training models, but we separating the training models more vertically, not transmitting parameters between the mobile phone to the base station. By doing that, we reduce the latency and we reduce the training separation as well as the requirement of the training devices. And we're not transmitting like the federated learning, we're transmitting the parameters up and down through the network. So therefore, we have, we can imagine for one single base station normally can connect it, theoretical limit is around 1 million, but normally at least a dozen of those devices. And then they will have a lot of more small computing power can work on the training and then applied to the larger model integrated together at the base station, the side, and then getting the training results. So this separation is becoming more vertically cutting the training layers, and then some smaller tasks can be trained at the mobile phone level, the small devices, and then the more complex and computing intensive one goes to the base station, the edge, larger computing devices. So furthermore, this is not only in theory, people are also starting, like Huawei, starting building such a model. So they start with the split federated learning model and to work out how that could apply to this wireless network, and to give a try on the split federated learning. So for us, when we're looking at the model, this is also enrolled into the 3GPP standard. So for ITU, normally define the vision and the big directions for the 6G, and then down to the individual programs, individual protocols, they will go to the 3GPP. And major companies are all telecom companies, even like Apple, also in the 3GPP membership, and they're proposing their own model. So this is type of AI and machine learning model already partially into the standard. And that will be leading future, potentially some of the work we could propose into the standard and becoming a part of the commercial development. However, there is a challenge. There are several problems to deploy such a split federated learning as proposed by Huawei. So one is the number of devices increases, and there will be very hard to transfer up and down those training parameters, as I mentioned earlier, and especially for some, most of our wireless network applications, we also require a real-time or near to real-time applications, and we want to have the more latency, have a smaller latency, and to accommodate the connection between the devices to the network. And the second problem is that when the edge devices need to their client models to fed to the server, and then to do the aggregation, and then incurring a lot of overheads. So these overheads is meaning you're not transmitting the either inference model or use the data. You have to occupy some of the wireless bandwidth, and those we will degrade the efficiency of the communication systems. So based on these two smaller problems, and we propose a newer efficient parallel speed learning model. And this model with the last layer aggregation and then the eliminating necessary model exchange, so that we can increase, reduce the overhead, increase the efficiency of the communication system. So this is the there are some other works we listed out how the like a vanilla split learning model and the SPFL like the Huawei proposed and a few others, and then with our model, and we compare some of the parameters and try to produce a more efficient, possibly could be used by the commercial companies. So this model have 7 steps, and from the client side to send the forward propagation, and then the activations, transmission, and then from the client side, and then from the server part, we do the model forward propagation and do the reverse back propagation as well, and then aggregate that at the activations. So the unaggregated aggregation gradient transmission, and then finally do the client model back propagation. So we complete the training process through a few 3 to 4 exchanges between the mobile devices to the base station to the server side. And then we do thousands of devices at the same time, and to do the parallel computing ideas. So for this, there will be a question asked that how much training will be done at the edge device. Although it have 23 flops for the iPhone 16, then we balance how much you are using for training, how much you are using for other application apps and things. So there will be a ratio between the training and other applications. So we design a aggregation ratio, and to control the ratio of the activation gradients that are aggregated at the last layer, as the diagram shows. So that will give a tailored way and to adopt to different applications. Then we're providing different training and upon the computing resources. So furthermore, this is a little bit theoretical study. We try to formulate what's the best way we can train the model, and we use a optimization technique, and then we're listing the parameters as mentioned down here to select different parts and to optimize the application. And through the process, and we work out the model, and it's becoming a mathematical problems, and then we transform into a auxiliary variables T1, T2. We further optimize, and then we decomposite the problem into 4 parts, and to reduce the complexity, and then we work out the mathematical steps, and using the BCD, the block coordinate descent algorithm, and to work out the problem. So with this model and training scenario setting up, and then we start doing some experiments. So we're taking the medical data sets and the handwriting recognition data sets is commonly used. And then we setting up the model by using, we're starting the simpler, the AI engine, ResNet 18, and then we're setting up the layers, separating the training parts into the mobile phone and the base stations. So with the model setting up, we obtained some of the results. So we can compare with the existing schemes, and the performance of our proposed EPSL more have better training performance and test accuracy as well as the latency significance can be reduced. So with the results, we briefly will summarize the idea of the paper we work out. This is a compute and communication efficient framework, and to aim to aggregating the last layer aggregation gradients, and then during the BP process to reduce the communication and computing overheads for the split learning. And then we building up the management and layer split strategy and try to optimize the communication subchannel power, subchannel allocation, power control, and the cut layer selections, and to minimize the per round latency. And then the experimental results compared with others, and we can achieve the faster and better accuracy. Based on this model, we are also done a few other works because that's only based on the ResNet 18. So we start looking at whether we can split all different other models. So we work with the split learning model was proposed by the MIT guy, Pratik. And we work with him and to do a newer paper already uploaded to the archive. We are doing the split LoRa for the large language model, and we have some results. We're finding is quite interesting. We'll produce further results very soon. And then for future, we are looking at several other things. For the other difficult area we're looking at is the data between the space, the satellites, to the ground. So there are a lot of data already in the space for remote sensing or other applications, and it's hard to the satellite link currently is very band limited, and there is not enough transmission bandwidth and to transmit the data out. So we split the model and for the training, and the satellites have very limited computing power as well. So we're looking at how we separate the training and the inference model results between the ground stations and the satellites. And then we're also looking at the hierarchy split learning stuff between the cloud edge and the user split learning, and then integrating with the large language models around the wireless network from the device to the base station. So we're looking at those stuff. So pretty much that's all I would like to share for today. And hopefully if we can sparkle some interesting common questions, and look forward to further collaborations. And if you're interested anything about Fudan, I will briefly introduce later as well. But this is the technical part. Thank you. Yeah.
Thank you. Yeah. And he's coming today because this week he's in Geneva to actually, I believe, influence future standards about this and also space internet.
Yes, it's more on the satellites, what the spectrum, what the model will be used in future. This week is the 5D meeting is the terrestrial network, and then the 5D study group 5 is all terrestrial, but they have a 5D meeting is how the terrestrial network work with the space network. And then this week they have the 4C meeting, study group 4C meeting is mainly talking about like a Starlink. They are all around and to looking at the spectrum, how they allocating the spectrum for future. And it's becoming a more interesting and more busy, like 190 countries researchers coming is overseas.
Wow.
The expectation, yeah.
Excellent. Yeah. Well, a lot of interest around today.
Thank you.
Any questions?
So when you are splitting the models about the edge device, you are splitting sequentially the model, or it's like a transfer split? How do you do this?
You mean transmit?
Yes. I mean, you are splitting the model over the devices. Did I understand?
Oh,
correctly?
we did not splitting the devices.
No.
The model is vertically split. Rather, so I think I go a bit too fast. Yeah, so it's more like this model for the this part is more like our the federal learning way. Where each of the network is the one for one device. So they training and then they exchange the parameters and then they aggregate it together.
The
And
network is not, sorry, the network is not split.
for federal learning is not split, but
Okay,
for our proposal, we split the network.
okay, but how do you split the network? Sequentially or?
Yes, depends on different layer, different the device computing power, and to split the network. Yeah, and there is a procedure in the later slides, and we then we choose. That's also a very good question. How is split? Is upon the data requirement and the computing power, then we're setting up a ratio to control how much split will be conducted. Yeah.
It must be very complicated.
Yes, I think that's the feedback we get from the industry as well.
Yeah.
The overall communication is hard, and then I think more they are pushing into the inference model. The training still done locally. Yeah. For the industry, we get a lot of feedback is on that. Yeah.
I'm sorry, but I didn't get what is the advantage of doing this? What is the purpose of doing this on training on iPhones or stuff like that?
Yes, this is a very good question. For our first imagination is that we have thousands of devices. Those devices, like iPhone, as mentioned earlier, have 23 flops already, so that we can utilize those devices to do a large language model training rather than we have a huge GPU data center and like either SpaceX or Amazon have those GPUs.
Okay, so the motivation is just mostly to use available resources that are not used.
Yes,
Okay.
correct.
It's
So
not
this
like,
is first motivation.
Yeah.
And then secondly, this from application level, we're looking, is this a big vision? And then down to the network level, we want to utilize the devices and to support the network so that what we are training the model is not like a generic AI applications. It's more for the wireless network optimization of the network. So that the other complex, this is a complex in nature of the AI, but we reducing the complexity of the wireless network protocol design so that they basically we're using the AI to reduce other complexities. So we try to balance out and benefits. Yeah. Yeah.
I have a question regarding either federated learning or the other one.
Yeah.
For instance, if we are training AlexNet,
Uh-huh.
first layer of AlexNet is learning edges.
Uh-huh.
So how do we aggregate two models when the first one, for instance, the first filter is learning vertical edges, the second filter is learning horizontal edges, but on the other model, we are learning a diagonal filter. So how can we merge that so that it doesn't become messy?
Well, yes, very good question. So we try to split. It's not. Firstly, I have to say, it's not all the models can be splitted. For the one for this paper, we tried several models, but we given the ResNet 18. So, but by setting the different layers and also, this is more like a specific problem with a specific model, rather than everything is generic, can work out to apply it to different applications. So what we try to split here is the ResNet 18, and then try to split in different levels, and which can aggregate together eventually. Yeah.
Because for ResNet, it's the same question actually, because the first layer is a convolution, but maybe this part is not aggregated, or because you are mentioning only the last part is aggregated for the
so correct. So for the steps, the last part will do the backend propagation, but the number 6 will do the aggregated aggregation gradient transmission. So they still have some back and forth transmissions, but the amount of transmission is much smaller than the federated learning model. And the other thing is that this is it depends. The other problem we have not completely solved is, although we would like to have a more in time or sort of near close to real time applications, and this latency we still cannot fully acceptable at the moment, because we all know, even for a data center, the training, even separate training models or from different clusters, the latency is also affecting the performance of the training process. And we still try to looking at the network and probably maybe city or around one base station, sort of split learning. And if large scale, because you have one base station or another base station connected with the optical fiber, and the latency depending on the distance, and will be large. Yeah.
Because how do you handle when one device cannot transmit? In practice, when one device cannot transmit to the server, how is it handled?
Sorry, I didn't get that.
If one device cannot transmit back to the server, how do you handle
Yes.
it?
Yeah, that will we have inaccuracy. That's in our I think in our second study we did try to understand that if there fault or BIOS, all these devices among thousands of those, and what sort of results or accuracy we can achieve. Yeah.
Curious question, maybe for future direction. Do you foresee this as always being a client service type of protocol, or as a client, like a peer-to-peer sort of protocol for joint training multiple pieces of the network?
Very good.
Always be the center point that does the aggregation and the creating updates and
it's more like a network, like a star network. Firstly, I foresee this is in future, especially for, we just try to looking at the model. Actually, the most we think the application is down to the space, because those satellites are all solar power, very low cost of the energy, and now the computing is more and more into it. And although it's currently is very limited, I can tell some of smaller satellite, like 100 kilo satellites, a satellite is only equivalent to training power of iPhone 16. But there are development in US, in China, they are developing the newer computing units. So if that's case happening, then naturally they will have such a split cases. But for this, we just try to start understand the problem. As I started early, I don't think this is more close to the application or industry yet. But maybe in future, we'll kick off a direction and to looking at the whole space, and everything is distributed, and how we can training the thing and For the satellites, there are low orbits and also there are the geo satellites and maybe becoming control and becoming a star network, and then or even the ground station. Yeah, the other way is that looking at this problem is already happened in Microsoft. They're building the data center just at the satellite ground station just back to back, and they put in a data center and then they do all of this training stuff. So I wouldn't see clearly. I would not have a clear application and directly can providing to industry yet, but I've foreseen this probably a problem to try to understand academically, to looking at the models. Maybe in future, if they come up, we'll accumulate some techniques, and then in future maybe it can be commercialized. Yeah.
You want to train with free energy of the sun and no cooling problems, right?
Yes, exactly. Yes, indeed, there are a lot of these currently the imagination. I have to say that way, but it's not a real stuff yet. But who knows? One day maybe they're becoming a thing.
That's why it's called collab cloud, right?
Oh,
It's a development platform we're developing here.
oh, really? Wow. Okay.
Joke.
Yeah.
The client side.
Yeah.
Is it used to use the compute power, as was mentioned earlier, or also to enable some forms of personalization, either individual or group level?
Yeah. Yeah, this is also very good question. We try to understand because different clients, it's not like everybody use iPhone, right? Some using less power. From our side, we have not solved the problem or understand. We only can or try to imagine on the model is that we only can choose the lowest level and try to unify the lower bound, and we have not have individual training schemes, split layers for different clients. We have not done that, and probably maybe is able to do that, but we have not done that yet. Yeah.
Yeah. I want to ask you, I want to ask, generally, do you have a relationship with the standards authorities like the ITU? And more specifically, does the ITU have a requirement for technology like this?
Very good question. That's why I've come to the meeting, and I wasn't.
He's here because he's at the ITU this week.
So that's an ITU meeting.
Yes. So
is it done, or are you?
No, it's not done. So how? Let me tell how the standards work, and in other area probably not do not need that standard a lot because it's more individual applications. So for two things, we think the standard is quite important. One is the communication as our mobile phone. You have to use globally. If each country they're using different standard, we do not talk to each other. This is back to 1990s. So in US we have DEC, in Japan, in Europe Terra, and then goes to GSM, and then in Japan they have their own system. China have their own system. Then eventually, because I studied this all the way, and then around 1992 or beyond, then the Europe becoming strong, the whole standard following the GSM. So every country, everybody using GSM. So then we can talk to each other. So that's the standard, how is useful for standard for such a scenario. And the second scenario is that currently, as I mentioned earlier, Andrea asked as well, is that we feel that in the space, everybody will put in satellites. And if they go all individually, then this is becoming a problem. They have to have coordination in terms of the frequency and in terms of where they sending the satellites. So those need standard. Once the standard coordinated, then for individual companies, they will producing techniques for such scenario. For example, for mobile phones. So what protocol you're using, what AI model you're using. and you have the patent, and then you submit to standards, and then the company using your patent, you get your money back. That's the logic. For the space, it's the same. So you sending out, I currently working on the other pathway of my work is on how we can put in satellites, how many satellites you can put into space without interference. So they have to coordinate, they have to have particular techniques, and then you put in more and without interfering others. And then I sell them to whoever need this technique. So that's the way the standard works. If I don't know how they coordinate, I don't know how to do my work. So
Is there any actually collaboration with Starlink because they have the most centralized right now in the orbit?
unfortunately, I haven't.
But
But
I mean ITU in general. not-
ITU, yes, there are a lot of Starlink providing a lot of inputs. So they're like what is it? Like our submitting papers. They do not submitting paper. They're submitting proposals, but the proposal is short, like 2 pages. They want a particular frequency, particular thing, and then all the countries have members have to discuss whether this is possible or not. And a smaller meeting, then every 5 years, there is a whole world meeting, World Radio Congress. That will be, next one is in 2027.
But concretely for Starlink, do they follow some ITU standard? So this is their own initiative and they created their own network.
For satellite parts, yes, they submit their requirements, and then because this is globally, they register globally, and then the later comers like OneWeb is earlier. Like China, is someone in China, they want to submit their constellation or satellite in space, they have to submit their proposals, and then the first come first serve. And then the later one, you have to finding out how you can avoiding your satellites, the coverage, all of this. Yeah.
Just a bit of narrative, and
Yeah.
those of you who know about standards, please correct me. So in the ideal world, standards would be like people on the known who decides how to make device interoperable.
Yeah.
And defining the interfaces and defining
Yeah.
the conditions.
Yeah.
In reality, for-profit organizations are using standard to push in their technology. That's what he was mentioning earlier. Like if I have a patent, I would try to push the patent inside.
Correct.
Standard, so everybody would use the patent and I would get revenue first.
Yeah.
So that's more or less how in practice.
Yes,
But
yes.
you need to agree on something, right? Let's say the Huawei
Yes.
and Starlink, they need to make some agreement, right? Otherwise, why they would even complicate it?
Yes, and that's a world that is pretty dynamic and
Yeah.
forceful as far as I know.
Yeah. So Starlink, Apple, Global Star, like Wiresat, so all major players are all in the meeting. Qualcomm like sending maybe like a ton of people. Yeah. Yeah. But I think for us is just observation for me because too complex. My group cannot handle everything. We just handle a particular problem in there and try to understand and whether our techniques can be useful or whether I steer my direction, my research group direction a little bit to accommodating this or not. But what I'm talking today, as I mentioned earlier, is more future reach. Whether happening or not, I'm not sure. Yeah.
Any other questions?
Yes, just from
Yeah.
a day-to-day user, since you're talking about splitting that on the edge devices such as iPhones,
Yeah.
is there a notion of how much power will be drawn from the phones?
Very good question. I think they're doing a lot, and is potentially is not sustainable as well. But what the Apple intelligence is already did is that they train our own habit to using apps and things already happening. They drain our power, but we don't know. I think that's happening. There have to be another way and try to utilize, because for iPhone, I think they have their own own drive and to do this because they make the user experience much better and you want funding apps according your habits and then they giving you quickly and user will accommodating and that as well. For the work we are thinking about is more like improve the link. You go somewhere without signal and we're finding ways quickly to maybe lower down some parameters of communication parameters, make you to have the communication. So that's a similar drive, but different approach. But both ways definitely drain the battery of your phone. How much this is a testing process. And we're working with Huawei and testing the phones. We don't know. We don't know what's the practical part yet. Yeah. And they can tuning the. So the other interesting problem I observe is that my phone in Europe sometimes can last a day. My phone in China, I use more 5G stuff, and then I can use like 2/3 of the day. So that there simply is the power between your phone to the base station, and that is dynamic controlled, and the user wouldn't notice of this if you are not in the area of work. Yeah.
Okay, Professor Gao, thank you very
Okay,
much.
thank you very much for your time. Okay.
Right. Free company.